Hello, today we'll talk about binary operations in Godot. First of all, let's see how the computer sees a binary number. This is the number 5, but the computer sees a lot of zeros and then 101. This is pretty much the same as having zeros in front of the number 5. It's still gonna be 5. Now the reason the computer is using this is because every integer has a fixed length. That way the computer knows where it starts and where it ends. In the documentation, we see that the smallest one is -2 raised to the 63rd, which means that the length of every integer is 64 bits. Now let's talk about negative numbers. This is -5. However, the computer does not understand the plus and minus signs. The first solution to this was to use the first bit for the sign. Let's use integers with smaller length for our example. Let's say we have 4 bits for every integer. That means we have 16 different combinations. Let's take number 5, that is 0101. As I said, we use the first bit for the sign, 0 for positive, 1 for negative. In order to get the opposite number, we change 0 to 1. 1101 is -5. And going from negative to positive is as simple as changing the first bit to 0. This, however, gives us a problem. 1000 and 4 zeros are two different ways to describe the number 0. Instead, we could have used one of them to describe another number. In order to fix this, we move on to a different system. Instead of changing one bit to get the opposite number, we change all of them. 0101 becomes 1010. And we do the same to find the opposite of a negative number. This is called ones complement because if we add two opposite numbers, we get all ones. Now, we haven't talked about binary addition, but it's pretty similar to normal addition. 0 plus 0 equals 0, 1 plus 0 equals 1, 1 plus 1 equals 0, and a carry of 1, which moves to the next column. If the last case looks confusing, think of this example in the base 10 system. 5 plus 5 equals 0 and a carry of 1, so we get 10. When we add opposites using ones complement, we only have the case 1 plus 0 for every column, and the result is 4 ones. As you may suspect, this means that we didn't solve our problem. 0 is represented as 4 zeros or 4 ones. And now we move on to what the computers are using, the twos complement. We use ones complement and then increase the result by 1. Now someone would think that in order to go from negative to positive, you have to subtract 1 and then use ones complement. Well, yes, but actually no. We can apply the same method as before. Ones complement, add 1, and we get 5. This has actually solved our problem with 0. If we represent 0 as 4 zeros, ones complement gives 4 ones. Increasing by 1, 1 plus 1 equals 0, we move the carry to the next column. 1 plus 1 equals 0, carry, and again until the end. And that gives us 1, followed by 4 zeros. Now, we said that every integer needs a fixed length of size 4. Therefore, we discard the last carry. And now we finally have a single representation of the number 0. Here's the numbers in all three systems to compare. Okay, back here I'll write a method to print a number in its binary form. We start with an empty string which we are going to fill with zeros and ones. As I said, we have 2 to the 63rd, so we have 64-bit integers. In the range function, we say 63 minus 1 with a step of -1. We use the plus equals to append to the string. Now just write what you see. We'll explain the operators later. And this is it. Let's try it. Let's say the number 5. I'll also show the integer in our label. Also, the reason I'm using print is because the binary wouldn't fit in the window. It's gonna be 64 digits. We have 5. And the binary is a bunch of zeros and 101. Now minus 5. I pass minus a in the method. We took this number, we changed the bits, and increased by 1. This is minus 5 using 2's complement. Alright, now we'll see the not operator. It performs the bitwise not operation on the int. Due to 2's complement, it's effectively equal to minus int plus 1. We have some examples here. Not 4 gives minus 5. Not minus 7 gives 6. Append the result in the label. By the way, the not operator is the button under the escape. Not A. Let's place it here as well. This changes every bit. It's pretty much 1's complement. We get 5 and minus 6. This is 5. All the zeros become 1's. 1 to 0, 0 to 1, 1 to 0. If we increase it by 1, it becomes minus 5, the opposite number. Let's try for a negative. Minus 5 and 4. This is minus 5. 1's complement. 1's to zeros, 0 to 1, 1's to zeros. This is the number 4, 1, 0, 0. Again, increasing by 1 gives us 5, the opposite. Let's move on to the OR operator. Performs the bitwise OR operation. This is useful for storing binary flags in a variable. We'll see that in the next video. Let's create another number. This is 11. We use the vertical line. And we get 15. Okay, this doesn't tell us much, so let's check the binary. The OR operation takes two binary digits, and if both are 0, it returns 0, else it returns 1. The operator works on every column separately, so we have 1 or 1, 1, 0 or 1, 1, 1 or 0, 1, 0, 1 gives 1. And the rest are 0 or 0, so we get 0. Now, the AND operator performs the bitwise AND operation. This is useful for retrieving binary flags from a variable. That's also for the next video. Let's just replace the line with an ampersand. And we get 1. Let's check the binary. The AND operation takes two binary digits, and if both are 1, returns 1, else it returns 0. 1 and 1, 1, 0 and 1, 0, 1 and 0, 0, 0 and 1, 0, zeros and zeros, 0. Okay, now let's move on to the XOR operator. Performs the bitwise XOR operation. We get 14. XOR takes two binary digits, and if they're different, returns 1, else 0. 1 XOR 1, 0, 0 XOR 1, 1, 1 XOR 0, 1, 0 XOR 1, 1, and 0 XOR 0 gives 0. Keep in mind we can also use negative numbers for these operators. Change this to -11. Start with OR. It still performs the OR operation. Same thing for AND and XOR. Okay, now let's talk about the binary shift. First, we'll see the left shift. It's the same as multiplying by a power of 2. B, shift to the left twice. This is the same as 11 times 2 raised to the power of this number. That's 4, 44. Here's the number. Basically, we took our number and pushed it to the left twice. Those two are discarded. We take the rest and place it at the start. And then, because the length has to remain the same, we add two zeros in the end. If we change this to 3, 11 times 2 to the third, 88. We took this number and pushed 3 spots to the left. We can also use negative numbers. It's still like multiplication. These 3 numbers are removed. The rest moves forward, and 3 zeros in the end. For some reason, we get an error if we use a negative value directly, but it works with variables. I'm not sure if Godot is supposed to allow this, or I accidentally found a way to bypass the error. If the latter is true, keep in mind that this bug may be fixed in the future. This number can also be a 0. We don't shift at all. In case we use a variable for how many times we shift, but the result remains the same, maybe we set it to 0 by accident. Technically, we can also use negative numbers. The result, however, might not be what you expect, which takes us to the right shift operator. A negative value means that we don't want to move to the left, we want to move to the right. It's the same as dividing by a power of 2. Well, not quite. I'll explain in a minute. Let's change the number back to 2 shifts. and change the operator. That's 11 divided by 2 raised to the second, which gives us 2. Remember, we get an integer, so 2.25 becomes 2. We take the last 2 digits, and the rest is moved to the end. And to keep the length the same, we add 2 zeros at the start. We can also use a negative number, but we get minus 3. Division would have given us minus 2.25, and then we went to the smallest whole number, which is minus 3. That's why I said this is not exactly like division. Again, take 2 digits, the rest moves to the end, and now because the number is negative, we add 2 ones at the start, instead of zeros. Again, we can have 0 or even negative numbers in the second operand. So if we're shifting by some variable, make sure that the variable is positive. Now the editor gives an error again if we use numbers instead of variables. So I'm not sure if we're actually supposed to use negative numbers, or this is something that Godot devs might have missed. I forgot to mention this, but we can also combine the operators with the equal sign. This is the same as a equals a or 6. If I print a, its value has changed. Same with and, XOR, and binary shift. Obviously, we cannot do that for the not operator. It only takes one number. If we want to update a, we type it like this. Okay, that's it about binary operations. In the next video, we'll combine them with enums. Till next time.